All right, we should be live. Finish getting this set up in just a moment. Howdy, howdy. Howdy, howdy, howdy. Hope everybody's having a good day. Howdy, howdy. All right, shall we get started? Oh, let me make sure. Okay, that's connected. That can be smaller, that can be bigger. There we go. Great day now. Oh, I'm glad I can bring you joy. Makes me happy that that's the case for you. Longtime fan of the astrosciences and new fan to your content. Been loving it. Oh, I'm glad I can do that for you, Nate. I appreciate that. Sorry that the live's a bit late. We had some friends in town and we wanted to grab breakfast with them. Well, I guess probably some questions will start popping in. From Steve Brody, can water be compressed? It can be, but it takes a lot of pressure and it doesn't compress that much. What advice would you give an 8th grader that wants to be an astrophysicist? Study hard, read as much as you can, like pop science books are fine, and practice your math skills. Math is super important. Which theory of gravity do you believe in and why is it better than newer theories? Well, the current mainstream theory is general relativity. If you're talking about like modified versions of general relativity or modified metric theories of gravity, like Einstein-Cartan theory, or if you're talking about Einstein-Gauss-Bonnet, or if you're talking about F of R, those don't necessarily fail, but until we have some distinguishing test that can distinguish between, you know, F of R gravity, say, and general relativity, there's not really a reason to prefer one of these over general relativity. Nightbot is on Vert. Yeah, Nightbot is on Vert. I need to figure out how to get it on both. Is there a way to observe things smaller than quarks? As far as we can tell, there's nothing smaller than quarks. There's just not. Do you think we will have graviton telescopes in 1,000 years? That's really hard to predict that far in the future. Arguably impossible. Why do particles have their specific mass outside of the Higgs? Well, that's why the Higgs boson gives them, like, they couple to the Higgs at a particular rate, and that gives them the mass. If a theory is mathematically off by 95%, is it wrong? Sure, but GR isn't mathematically off by 95%. It's false narrative. From Steven, or at least it's not, we don't have evidence that it's off by 95%, right? From Steven, Blitz, genuinely want to know if you're going to ever comment on the Epstein files. What's the comment on? It's disgusting what's in there. How do you feel about PBS spacetime? It's brilliant. It's probably the best physics explainer channel that exists, in my view. What's your... Oh, that's not a question. Theoretically, what's the largest amount of smoke you could fit in a room? Oh, I don't know. I mean, you could just keep So, okay. Smoke is basically suspended dust. That's like incandescently glowing, meaning it's really, really hot. The thing about smoke is that, like, you can't just like keep it in a room stationary. Eventually it'll settle, right? Unless there's like some heat source that's causing convection. Gravity falsifiable? Yep. You just got to take one of the predictions of gravity, like, for example, take a prediction of Newton's universal law of gravitation, and then you can run the Cavendish experiment and check to see if the force does not go as 1 over r squared and is not proportional to the masses. How do you feel about the multiverse interpretation? I think it's pretty good, generally. Can you explain why Mars has tear-shaped analemma and Earth has figure 8? I imagine it has to do with the... Well, so one, it's going to have to do with that Mars's orbit is eccentric. I don't even know if it's true, by the way, that Mars has a tear-shaped analemma. Earth's is almost tear-shaped. It's just like the bit at the top is like, if you imagine that like the figure 8 was more... Yeah, so this has to do with where the equinoxes are relative to where the closest part of the orbit is what what it would boil down to. So I guess Mars is much closer to Mars's orbit and axial tilt alignment they're much closer to each other. They're much more like in sync than they are on Earth. So you're going to end up with the crossover point much closer to the top. If the speed of light is the speed of light slower now than in the past? Well, this is an idea that people talk about, but we don't have any like smoking gun evidence that that's the case, as far as I know. How do you think the universe started? How can something come from nothing? This keeps me up. I don't think anything did come from nothing. I don't think that there was ever nothing and then there was something. Either the universe has always existed, like time, there's for every moment of time there was a moment before that, or there was a first moment of time, but there was some spacelet, or there was some non-temporal state beforehand in like a geometric sense, not in a temporal sense. What are the odds the Big Crunch theory is correct? I wouldn't put odds on that. I wouldn't be able to establish like a probability odds for that. I'm surprised you're okay with the multiverse. I thought you were following Penrose's lead. No. A lot of ideas of Penrose's are very good. I think conformal cyclic cosmology is a really good idea, but it seems to have been falsified, or at least seems to not be particularly well evidenced as it stands. We have a super chat from Pumpback with the $2. Can Ubisoft bounce back or only in alt reality? I have no idea what that means, but thank you for the $2. And C-Bar, thank you for the $2 as well. I appreciate it. How much energy would be involved in an object in orbit weighing 1,000 kilograms moving at 17,500 miles per hour? Well, you could compute that. All you have to do is compute the kinetic energy. Take 1/2, multiply it by the mass, and then multiply it by the speed squared. Now, that's not going to be in joules. It's going to be in a different unit because you're in miles per hour rather than meters per second, but it's a lot of energy. There's a lot of energy involved in orbits. However, you'll also have to take into account the gravitational potential energy, which is negative. Now, it doesn't cancel it out, but it does reduce it by like a factor of 1/2 if you're in a circular orbit, if I remember correctly. And no, I'm sorry. I should correct myself. So the gravitational potential energy is more negative than the kinetic energy is positive, so the net system will have negative energy. But that's exactly what you would expect, because bound states should have negative energy. Otherwise, it would not be a bound state. I've heard protons don't experience time. What the fuck are they doing for the time it takes to hit my eye? You're talking about photons. Photons, they don't have proper time, but that doesn't mean that they don't have a past and a future, right? They definitely do have a past and a future. They just don't have measurable durations. Higgs doesn't give all particles mass, though. That's true. Higgs doesn't, as far as we know, the Higgs doesn't give neutrinos mass. And I guess in some sense it doesn't give itself mass, right? What do you mean a pre-temporal state? So you could have a state of, like, the universe could be in a state where it's just pure space, where you have a four-dimensional space rather than a four-dimensional space-time. And so one could imagine that that is in some sense geometrically linked to the first moment of time where it went from space to space plus time. Skip down to the bottom so I don't fall too far behind. What's the name of the guy who came up with the flat earth theory? Starts with an R. Well, the modern flat earth theory started with Samuel Robotham, as far as I know. Can we say a black hole same as the bubble if we tap hard enough using a palm to a glass ball, or just pure empty space? No, not really. It's not really a good intuition for what's going on. Is the time in general relativity and the time in quantum mechanics the same thing? Not really, no. Time in quantum mechanics is just viewed as an external parameter. It's just like a thing that happens external to the system, whereas in general relativity, time is like one of the things that the theory describes how it behaves. How would you measure space without time? Why do you believe that? Fascinating. Well, I'm not saying I believe this, by the way. I'm just saying that this is like something that is at least plausible, or possible anyway. But like, there's no reason why you couldn't have space without time. This is like, there's no physical or mathematical reason why you couldn't have space without time. what are modern takes on Bohmian mechanics? Some people are still trying to make Bohmian mechanics work with special relativity and quantum field theory more generally, like generalized quantum field theory. My understanding is that they haven't been so successful, or at least they haven't convinced all the rest of the physics community that they've been successful. Where would a neutrino get its mass from? Neutrinos get their mass from, we don't know. We actually don't know where they get their mass from at this point. It could be from the Higgs mechanism, but it would be a little bit weird if it was. When people say that a positron is an electron, why people say that a positron is an electron that goes back in time? Because if you look at a math, an electron that travels backwards in time would look like let me rephrase. The solution to the equation that describes a positron would similarly well describe an electron moving backwards in time. Are all magnetars neutron stars? They are. They absolutely are. How does an electron know it's being observed? Because you're doing things to it. You're interacting with it. Do you understand how quantum computer works? I mean, like, at a level deeper than the surface level, yes, but not at the level of an expert, no. Can we attribute a nuclear reaction to messing with the fabric of existence? No, I don't think so. Dude, you're making physics so hard overthinking I can explain everything to a 5-year-old like a movie. Ah, okay. I'm having a hard time understanding a non-temporal state preceding a temporal state. Isn't the idea of preceding a temporal state? Right, so I'm saying it's a non-temporal notion of precession. So this is like a geometric notion. Imagine, like the thing to imagine is that, like, you want to think about all of the universe, like the space-time or whatever it is. You want to think of it as like a whole four-dimensional thing. And so you could have a part of the four-dimensional thing where there's time glued to a part of the four-dimensional thing where it's only space. And then you could follow a trajectory backwards in the four-dimensional space-time, and eventually you would get to a point where the coordinate or the coordinate that you were using to mark off like moments of time, as you continue following the same trajectory, would just become space. So it's proceeding in the sense that if you go back in time and then you follow along the same trajectory, you would, if you trace out the same trajectory, you would go through space, but like, of course you can't actually move, but like you could imagine drawing a line through this four-dimensional thing. And for part of it, there would only be space. And for another part of it, that line would trace out moments of time. That's the idea. There's no actual temporal precession here. Where can you find my notes? If you want access to my notes, which again are not like, they're not intentionally made for the public, but if you want access to my notes, it's $4 or $5 a month. You can become a member on YouTube or become a member on Patreon, and you'll get a link to my notes. I've heard that in CERN they've managed to get anti-hydrogen. How can that be sustained? Well, it's not. They can't store it for very long, but they can produce it for a short time. Why study for 6 years just to become a science fiction theorist? Well, I don't know. I don't know anyone who's done that, so I can't answer that question. Does a light speed was measured in an empty space or no? And can it mess with the light speed too? Also, can the sensor that detects it have a delay or no? So the first time the speed of light was measured, like in an experiment on Earth, of course it wasn't done in empty space. It was done on the surface of the Earth. And they didn't really use a sensor. It was a little bit more of a sophisticated method than that, where it doesn't like rely on like a delay with some electronic. It was something like, it's a little bit hard to explain, but I do have a video on it. But suffice it to say, they measured it on the surface of the Earth, where light travels a bit more slowly than it would in a vacuum. But we have measured light in a vacuum, yes. And like these things have absolutely been measured with precision, accounting for any sort of electronic delay and so on. Imagine wasting your money and degree on physics. Well, I didn't pay for my degrees, so I didn't. I've recently been seeing your content and I've been a huge fan. Well, I appreciate that. Could you talk about quantum foam? I do have a video on this. Quantum foam it's just this idea that like, if you try to measure what seems like empty space, you will never measure nothing. And the reason for that is merely because the act of measuring disturbs the quantum vacuum. It's basically that. And the quantum vacuum isn't like genuinely empty, right? From Vladdy, do you have 5 USD per month notes on category theory? No, these are just debate notes. It's just like sources and stuff like this that I use personally when I'm doing debates. Is stream just starting? I just got here. Yeah, we started 15 minutes ago. You take a slice of the bread, and you examine it, but it was past, future, and present, and that is okay, I don't know what that question means. Are there gravity particles? We don't know, but it seems at least plausible that there are. I heard Penrose say that quantum mechanics goes wrong at high mass displacement. What does he mean by that? He thinks that he thinks that relativity is perhaps more correct, and that rather than trying to quantize gravity, we should try to geometrize quantum mechanics. So he thinks that quantum mechanics is going wrong when we're talking about heavy, massive things where gravity would play a role. What is the inside of our galaxy? What's their helium? I don't know what that question means. Our galaxy is made of stars and dust and dark matter. How did the first galaxies come to be at the end of the cosmic dark ages to reionize the universe? Well, so stars formed before galaxies, or at least plausibly that's what happened. I mean, they wouldn't, I don't know if we would call them galaxies if there weren't any stars and dust. But I mean, they essentially would have just, at least some models suggest that they would have just coalesced around basically primordial fluctuations where there was slight overdensities, and if you have slight overdensities, then you have slightly more gravity attracting to that slight overdensity, and then you can get a whole bunch of matter coalesced around it, and you can end up with stars and the like. I have to scroll down because I'm a little bit behind. From Joshua Everett with the $5. I had a friend in school theorize that the speed of light was set by the max speed of the initial inflation event, edge to center. Any truth to that? No, not at all. At least we don't have any reason to think that. Would twisting an indestructible rod across 100,000 light years be seen simultaneously? Time dilate? Okay, so this is a question about this is actually like a fairly common question, and people ask it a lot, and I appreciate the question. The idea is merely if you take like an indestructible rod and you and it's really long and you flick it, would the other side move faster than light, basically? And the answer is no. And the point is that the fact that special relativity is true means that you can't have perfectly rigid objects. Objects have to deform even a little bit. Unlike in Newtonian mechanics, you can assume that they're perfectly rigid objects. Perfectly rigid objects would be objects whose speed of sound is infinite. In special relativity, we know that that can't be the case, which means that you can't have these perfectly rigid objects. So even if you push on one end, the far end will not notice that you've pushed for a very long time, because the pressure wave of you pushing on one end would take time to travel down the length of the rod. What's the difference between a mathematical physicist and a theoretical physicist? The difference is that some physicists will think I'm a mathematician, and some mathematicians will think I'm a physicist. Theoretical physicists are never confused in that regard. How do they manage to isolate single particles to study and find the other one quantumly linked to? Well, they make them entangled. So one way that you can do this is you can start with something called a nonlinear optic, and you can shoot individual photons through. You can do this by basically putting sufficiently dark filters in front of a light source, and eventually you'll just get single photons passing through. You shoot that through a nonlinear optic, and that single photon will split into two. And if you split it, and if it's split into two in just the right way, at just the right angle, then those two particles are automatically entangled. What do you think of string theory in the 11 dimensions? Well, in string theory, there's 10. In M theory, there's 11. I don't think that string theory is a theory for our universe, but I think that it's a correct theory for a physically possible universe. And I think that it can teach us a lot about how quantum gravity should behave qualitatively. How do they isolate protons? Well, it's not that hard. Do you mean single protons, or how do you get protons alone away from electrons and neutrons? Because getting protons alone is pretty easy. You just take hydrogen gas and you heat it up a lot, and then you pass it through a magnetic field, and the electrons will go one way and the protons will go the other way. But to isolate single protons, again, all you have to do is you can just basically put a really thick filter or a really thick block of metal and shoot the protons through, and eventually you'll get single protons coming out the other side. There's probably more sophisticated ways, but that's the easiest way that I can think of. I studied GR and I don't understand how in de Sitter different coordinates mean different physics. different coordinates don't mean different physics? Or are you talking about things like horizons and the like? So what you will notice is, regardless of your coordinate system, like a geodesic observer, free-falling observer, if you will observe the same thing, regardless of the coordinate systems. Is there a center of the universe? Do we know where it is? As far as we can tell, there is not. Higgs field, has it been looked into whether this could cause gravity? The Higgs field is not really related to gravity, no. And people have tried. Any tips for studying complex analysis? Do your contour integrals? I don't know. Complex analysis, I'm not really fond of it. Why do physicists suggest that giving up realism brings back localism when Bell's proves non-localism? No, Bell's inequality, or the experiments that prove Bell's inequality is violated. Bell's inequality requires that you can't have both realism and locality at the same time. Namely, you can't have local hidden variables. But you could have, you could get rid of realism, and then you could have local properties, as long as those properties are not, sorry, you could, if you give up realism, then there's no definite properties for the particles. And then you have locality. And in fact, that's kind of what the many worlds, or it's not quite what the many worlds interpretation does. That is what like kind of a standard way of understanding quantum mechanics is, namely that, disregarding the collapse bit, but you can just have particles that have spins that are not well defined and are entangled, but without transmitting any signal or you know, having any superluminal cause and effect relations. You can get that from Bell's inequality, so long as you give up realism. And many worlds interpretation in some sense does this. All right, I have to skip down to the bottom. We have some super chats from KF Systems with the €2. Why did the universe start at a low entropy? Arguably, the reason we call the universe starting 13.8 billion years ago is because it was in a low entropy state. If the universe was, we would say whatever is the low entropy state, we would say that that's the beginning and that time flows away from that. That's one way to view it. So if your question is why was there ever a low entropy state, that's a different question that we don't know the answer to. From Binary Ghost with the $5, there is a center of the universe. It's wherever I happen to be. True. That's a good point. Could consciousness be fundamental to reality? I guess it could be, but like, I don't think that it is. Where are the God debates? Not on Tuesdays and Wednesdays. Is multiverse the best response to the fine-tuning argument? It's definitely the simplest response. And if you just don't want to have the conversation, you can just say, okay, well, the multiverse adequately explains this. I don't know if it's the best response though. What's the amplitude of a photon? A photon, okay, so it's not really like a sensible question. If you're asking like how strong is the electric field for a spherically, well, you can't have a spherically radiating photon, first of all. So a photon will never have a single amplitude. Uncertainty principles and so on will prevent that. Photons are, what they will have is they can have a well-defined momentum, but if they have a well-defined momentum, well, okay, I guess they could. Yeah, can they have a well-defined amplitude? Not really, insofar as a photon isn't a plane wave that extends in all directions forever, at least not a real photon. How do photons know they're being photons? I don't know what that question means. Photons are photons. How do photons know they're being observed? They don't really. Like, they just are interacted with, and when they're interacted with, things happen. Can you explain why trees do not grow to the size of Devil's Tower? Because Devil's Tower is not a tree. Never was. Is it possible that the universe could just stop expanding completely and just freeze? It's likely not possible. I wrote a paper on this last year, this is something called a long freeze scenario. And long freeze scenarios seem to be excluded from standard general relativity. unless you have some degree of fine-tuning. Could the low no entropy state be space without time? It's really hard to define that kind of thing, like entropy in like a in those kinds of non-standard settings. Which is better, astrophysics or astronomy, to choose as a major in college? It just depends on what you like more. Why was there more matter than antimatter at t equals 0? We don't know. That's an open question. There was a higher entropy state to both sides of a low entropy state. Would that produce two universes with time vectors opposite each other? That's one possible explanation, yeah. Absolutely. And it's called the Janus universe. Janus universe. If it stopped expanding, then there would be something stopping it from expanding, right? Yeah, the idea is that you could have like the dark energy, the amount of dark energy could change in just the right way, that like the dark energy changes in a way that causes it to slow down and stop, but not keep contracting. Man, some people are really salty. This freaking lying loser. Okay, you can be upset. What's your day job like? What kind of tasks do you have to do? Mathematics. So currently my day job is half this and half research. So I mean, you guys know like what this part is. Like I write videos and I write, film, and edit videos, and then I do live streams. The other half is it's often, there's a lot of writing involved, writing papers, but there's a lot of calculations. So like I have a big book, actually this book is, I'm reaching the end of it, but just like, there's just like books of, like just pages of calculations that like, and I have dozens of these books, maybe not dozens, I probably have actually like half a dozen of these kinds of notebooks filled with calculations from the past few years. Just trying to work out various mathematical proofs or trying to derive various like predictions for models of whatever kind. It's just that kind of stuff. It's mathematics mixed with physics. So there's a lot of calculations involved, and a lot of reading of like what the existing literature says about various things. From Jerry Riley, happy Black History Month. Happy Black History Month to you too. Could you help me understand what the magnetic and electric vector potential represent? From an EE standpoint, I simply use them as mathematical tools to solve field problems. So we typically, you want to talk about an electromagnetic four vector, which has an electromagnetic potential, or an electric potential, an electric scalar potential, and a magnetic, an electric vector potential. It's really hard to like I don't really have a good intuition for the magnetic vector potential. I know that you can talk about an electric vector potential, but like it's always easier to me to talk about the 4 vector, which is just one thing. I guess the way to think about it is, what's the right way to think about this? I guess I just don't have a very strong intuition. I mean, the scalar potential is fairly easy because you can just think of it as like, in some sense, encoding something about like how the charge is distributed, but the vector potential is really hard to get some intuition for. So, I mean, yeah, definitely it's treated as more of a mathematical tool, at least if you're doing classical mechanics or classical physics. Is the observable universe not a perfect sphere because we aren't a fixed point observer, we spin and orbit and drift? The observable universe for any individual person would be a perfect sphere, assuming that expansion is isotropic, or yeah, assuming that expansion is isotropic, meaning the expansion is at the same speed in all directions. The observable universe is not like centered. The observable universe is literally centered on each individual observer, and in that case, it's at least idealized to be a perfect sphere. How often do you check that one small error doesn't throw off pages of calculations? I try to check pretty frequently. From Tom McBoatface, thank you for the 1 Canuck buck. I appreciate that. If you can do math with the universe, I think it's fair to say there is a God behind the universe. I don't agree. From Beef Brain with the $5, what do you think about the claim that quantum mechanics proves that either there are many worlds or physicalism is false? Would you agree with this? No, I don't think that holds at all. Physicalism just makes the case that like things are, like the things that are in the universe are physical, which in some sense means something like describable with physics, which I get is a little bit circular, definitely. But I don't think that, yeah, I don't think that that's a dichotomy. Can gravity waves do anything to us if big enough? Yeah, I made a video on that a while ago. They'd have to be really, really big. Like, really big. You'd have to be, like, miles away from a black hole merger. What's the odds that dark matter is regular matter? Oh, 0. Otherwise, we'd be able to see it. Does visible light have other properties that set it apart other than us being able to perceive it? No, not really. How is antimatter contained? With magnets. What do you think about the new development about cosmic knots explaining the matter-antimatter imbalance in the universe? I haven't heard about this. And you guys have to understand, so these pop science websites, like Popular Mechanics or like Scientific American, these will often latch on, or any of the dozens of websites that do science reporting, these will often latch on to some like cool sounding new theory or new hypothesis or new idea that like potentially explains XYZ. But most of the time, those ideas are like one researcher or like one or two researchers that put out a paper, and it's like a neat idea. But like there's like it's just that. It's just like a neat idea. It's not some new development that people accept. Like this is just an idea that would need like decades or years, perhaps decades of further testing to see if it's real. And almost certainly all of these ideas are going to be wrong. Very, very rarely will there be a correct explanation that's new. From Tom McBoatface, again with the 2 Canuck bucks, thank you. Does dark matter exist, or is it a math hack for GR? We don't know, but dark matter seems to be winning this fight. Because even if you look at most MOND theories, these are modified Newtonian dynamics theories that kind of try to account for the rotation curves of galaxies without dark matter, even most of those, the modern ones, that like stand up to other tests, they include some amount of dark matter, just less. And from Texas Panhandler with the $5, do you think humanity will ever travel into space? I mean, we already have. But if you mean far away, that's a different question that I don't really know the answer to. I can imagine that we could colonize our solar system. Going to different stars is probably a long way off. But, you know, maybe we'll invent warp drive. V equals pi r cubed is a mathematical formula to a sphere. No, it's not. The volume of a 3-dimensional sphere, or really it's called a 3-dimensional ball, it's 4/3 pi r cubed. You're off by a factor of 4/3. Utop just crashed. Yeah, he does. Do we know what happened in the first 380,000 years after the Big Bang, and does this theory contradict with the law of conservation of energy? No. So yes, we do know, and no, it doesn't contradict with the law of conservation of energy. Keep in mind, the law of conservation of energy is only like an approximate law that holds on Earth. It doesn't hold globally on a cosmic scale. Did you watch the moon launch or the Super Bowl? I didn't watch either. What is dark matter, and why do you not know 70% of universe, yet you can talk of God, i.e.? Well, so dark matter is likely a type of particle. I don't see how not knowing what the particulate makeup is of a particular kind of matter has to do with whether or not a God exists. That seems kind of irrelevant. What countries are best positioned to lead the field of theoretical physics over the next decades? I imagine that it'll probably be, I mean, if the US turns it around, which I don't know if it will, but if the US turns it around, it could be the US. China is producing better and better work now. Japan has consistently done good work. Poland, at least in my field, Poland has always been good. The UK has been good. Yeah, I mean, honestly, there's like a lot of good countries that are doing good work. Most of the work is pretty international too. Skip down to the bottom. From Tom McBoatface with the 2 Canuck bucks, what's the Higgs boson and why is it a scalar? So the Higgs boson is a type of fundamental particle. What we mean when we say it's a scalar is that it has no intrinsic angular momentum. You could give it angular momentum by like making it go around something, but it doesn't have any angular momentum on its own just existing. Now, why it's a scalar? I mean, it could have been like there were ideas before we discovered it. There were ideas for something called like a vector Higgs and things like this, but it's just the one that we have in our universe is a scalar. And the Higgs boson, I didn't fully answer your question. The Higgs boson is the excitation of the Higgs field, and the Higgs field is the thing that's responsible for giving many fundamental particles mass. From Dr. Carla, thank you so much. Good to see you with the $5. I'm not a physicist. In your opinion, what science-related popular press serials are best for the layperson? Thanks. Hashtag I love lamp. Well, I like Scientific American a lot. There have only been a few times where I've seen a Scientific American article and it was like poorly conveyed or poorly written. I've called them out a few times on it. I've made videos about like when their articles are not good, when they're like being either deceptive or wrong. But generally, Scientific American is really good. Popular Mechanics seems to be less good, but it's still good. Quanta is generally really good as well. Quanta Magazine. So I'd probably say those ones. Those ones are probably the best in my view. All right, let's see Alexander's all caps again. It's just funny, so we have to highlight it. If dark matter is energy likely and you don't know what you can't see now, how do you then claim to see 365,000 years ago? So dark matter isn't energy. And you don't know what you can't see now. What? How do you then claim to see 365,000 years ago? Because light takes time to travel. If light takes time to travel, then if you see light from far away, then it's old. But I love the all caps. That's really that's really cute. As speed increases towards the speed of light, time gets funky, right? The further and further we want to go, the less feasible it is to get to, even if we go faster, right? No. So the convenient thing is that if you can go really, really fast, then the amount of time it'll take from your perspective to get somewhere decreases much faster than you'd think. So if you go at 99% the speed of light, say, from your perspective, traveling 1 light year will take less than a year, because it won't seem like you're traveling because of the length contraction from your perspective. The thing that was 1 light year away is now actually much closer, and it's still traveling towards you at the speed of light. It's just from other people's perspective, it'll always take at least a year from their perspective for you to travel that distance. And from Mr. Pecho, I can never remember, Pecho? I know your real name, so you know. Thank you for the $20, bud. I can do math. I'm horrible at physics. Setting up problems using theorems correctly seems like a completely baffling skill set that I just don't have. Is there one weird trick or strategy I should learn, or just practice? You're approaching it the wrong way. Theorems is not how you do physics. You don't use physics using theorems. You do physics using intuition, basically. You use intuition, and then you think about what's the right equation that fits here, and you go find the right equation. The equation that was maybe derived from XYZ thing. It is a different skill set, though. It is a very much different skill set from doing mathematics. And developing intuition is something that takes time and practice. And so like I have pretty decent intuition for things like asymptotics and relativity. So like my intuition's pretty good there. My intuition is like ass for quantum field theory. From Git Stanfield with $5, is the heat death model still the consensus in astrophysics currently? Also, are there any new insights that the James Webb provided? Thank you. So astrophysics doesn't deal with heat death. That's cosmology. So it's not astrophysics, it's cosmology. Second thing, heat death is probably still the consensus insofar as there were data points over the last few years that indicated that it might not be, but those are still contentious, and there's still further analysis and further verification that needs to happen there that would show that indeed, you know, if that indeed perhaps dark matter or dark energy, sorry, is dynamic. If dark matter is dynamic, then heat death might not be the only expected outcome anymore. But this is still up in the air. And as far as JWST is concerned, I haven't heard of anything new. And from Lou, thank you for the $5 Australian. No question, just appreciation. Thanks for all you do, Blitzy. Well, I appreciate you, Lou. How does Penrose's singularity theorem apply to reality if affine time doesn't map to it? Okay, Kerr. Shut up, Kerr. Just got here. What does dynamic mean in this context? It just means changing. The idea, the kind of the standard model idea, I shouldn't say standard model, the standard kind of consensus view for dark energy is that it's sourced by something called the cosmological constant, which means that the energy density, so if the amount of dark energy in a given cubic meter of space is fixed forever, never changes, and so that makes the universe's future very predictable. But if that amount is changing over time, then everything goes out the window. It's much harder to predict what's going on in the future. Quantum entanglement, can you explain why and how? Well, why and how are kind of the same question when we're talking about physics. Like why typically, like we expect some sort of reason, like some sort of intent or agency. But when we're talking about things that don't have that, we generally don't ask why, we ask how. So what quantum entanglement merely is it's just the failure of, at least this is one way to think about it. It's the failure, actually, let me back up. So there's kind of this deep idea that's kind of boiling under the surface of the physics community, that space and perhaps even time are emergent from underlying quantum processes. And so the idea is that on a large macroscopic scale where no quantum stuff is happening, like where we can approximate it as classical, there's not really any relevant amount of quantum entanglement. And so it makes sense to talk about things being at different places and being separated from each other, and you know they can only talk to each other by sending light signals or by communicating in other ways or whatever. One of the ideas is that quantum entanglement might be a breakdown of this idea that spatial separation emerges from quantum mechanics, that only happens when your quantum system is behaving in a certain way, and in other scenarios, which are much harder to achieve, they're much rarer, this notion of spatial separation is just no longer valid. And so one way to think about quantum entanglement is just that you have a quantum system that is not well described by a quantum system that well approximates, or it's not well described by a quantum system superposed on top of a spatial of a universe with a spatial dimension or spatial dimensions. It's rather something that kind of lies underneath it. And in the case of that particular quantum system, the spatial stuff just doesn't emerge from that kind of quantum system. And so it might be the case that quantum entanglement is kind of the breakdown or the failure of space to emerge from quantum processes. Now, what quantum entanglement really is, it's just when you can no longer describe a quantum system in terms of the individual particles that make it up, as this is the state of this particle, this is the state of this particle, and so the state of the whole quantum system is just the combined states of the two particles. It's really, these two particles are part of the same thing. You can't describe them separately. And from Dark Nebula with the 14 ZAR, ZAR, do you think there are logical arguments for God? I mean, there are. They're just not necessarily compelling, right? From Optopoppet with the $10. Thank you so much, bud. Good to see you. Assuming no outside interactions, is quantum entanglement permanent or does it decay over time? Also, can you measure one of the entangled particles without destroying the entanglement? It is permanent, yes. And yeah, can you measure? The thing is no, you cannot. Well, okay. Yeah, so you can't measure a single particle without breaking the entanglement. What you can do is you can change one of the particles in a way that'll just change the entanglement, but you can't. I'm just trying to think about this. So you would have a Hamiltonian, an interaction Hamiltonian that interacts with one bit. Actually, yeah, you could. Oh, could you measure it? No, you can't. Correction. You could measure something. So particles don't have to be like fully entangled. It could be the case that you have a particle whose spin is entangled, but whose, say, energy, or I shouldn't say energy, maybe we would say whose momentum, whose linear momentum is not entangled. So they might have well-defined separate linear momenta, but the angular momentum are entangled, so they always flip. So you can measure the linear momentum without affecting the angular momentum, which wouldn't affect the spin. Or, sorry, wouldn't affect the entanglement. So yeah, you could, but you can't measure the entangled quantity, basically. Do you think the universe appeared on its own, or did something or someone cause it to be created? If you think it just came from nothing, then why do you think that? I don't think it came from nothing. I don't think that there ever was nothing. You're good at remembering what you read. At least I know how to read. By the way, this is the guy that was super bad faith and insulted my mom yesterday, so it's okay to be mean to him. What are the most logical arguments for God? I would like to research them. I mean, just go look up any like genuine academic philosopher who's also a theist will give you arguments. What it takes to become a physicist at research, talent, or just hard work or understanding theory? It's probably a mix of all three. I think that video, by the way, the video with 85, I think it went up yesterday. So if you guys want to see, a Buddhist crash out, which is hilarious, by the way, like some Buddhist apparently doesn't have Zen. If you want to see a Buddhist crash out, the video is currently live on the Dr. Blitz Debunks YouTube channel, entitled, I'll actually just show you what it's called. I'll actually just show you the video, and because it's a really funny video. Yeah, here it is. So here's the video. It's exceptionally funny. So go watch it after the live stream, of course. It's live on the Dr. Blitz Debunks YouTube channel. And make sure to subscribe to that YouTube channel in the meantime. From Texas Panhandler with the $5. Do you think humanity will ever travel into space? We already have. If you're asking if you think that we will ever like go amongst the stars or even travel between galaxies, I don't know. I think that it's plausible that we will colonize our solar system in the somewhat near future, like over the next 100 or 200 years. I don't know how plausible it'll ever be for us to go to other stars or planets around other stars, and I don't think that we'll ever leave our own galaxy unless we invent some sort of warp drive or something. By the way, if you're already going to that YouTube channel, make sure to subscribe to it. And if you want, if you're 18 years or older, join the Discord server. It's discord.gg/drblitz. Just go there and enjoy it. There's a lot of like-minded people there. You can ask questions. You can get announcements for when I'll be live, announcements for when I post videos, and etc. So it's an interesting place to be, and it's a good community that we're building. From Git Stanfield with the $5. Out of all interpretations of quantum mechanics, which one do you adopt and why? Also, how common are neutron stars in our galaxies? So 2 questions. First, I tend to lean towards the many worlds interpretation, although I recognize it does have its flaws. I adopt it because it seems like it's mathematically simplest, and it takes the mathematics at its at face value and then just doesn't add anything else. That's all. And how common are neutron stars in a galaxy? I actually don't know off the top of my head how common they are. I know that they're definitely far less common than stars like our sun. And the reason I know this is because neutron stars form from supermassive stars when they at the end of their life after they go supernova. That's how neutron stars form. And bigger, heavier stars that are much, much brighter are much, much rarer than smaller, lighter stars. Thinking that the Van Allen belt is impossible to cross is just a massive misunderstanding of what it is. That's true. Actually, I want to know, because if there is nothing, it's only the absence of something that will be there, but I want to know if there is something that will stay at zero forever, like actual zero. I don't know what that means. From Garain with the $5. I'm atheist, but struggle with squaring fine-tuning, other than evoking anthropic multiverse explanations. Why is fine-tuning not a good argument? Well, look, so fine-tuning, there's a few issues here. What fine-tuning does is it pushes the buck back. Like, even if you take all of it at face value, it pushes the fine-tuning back to the will of the creator, right? If it's the case that our universe is fine-tuned for life, for this kind of life, well, why tune it for this kind of life? Why not just tune it for some other kind of thing? You have to then ask, well, even though it's true that the amount of possible ways the universe, even if you grant that the amount of possible ways the universe could have been that admit life is much smaller than the amount of possible ways the universe could have been that don't admit life, it's still the case that there is an enormous parameter space for ways that the universe could have permitted life, and that life could have been very different. In fact, it could have even been the case that the universe isn't, it could have been the case that the universe just doesn't allow biological life to form, but this creator being just infused electrons, say, with minds. And so the question is why did this creator choose to make the constants this way to create this kind of life rather than some other way? So it seems like it's just pushing the buck back a little bit further, and it doesn't actually answer the question as to why the constants are the way they are. Secondly, it seems like even if you think that that's not a problem, it seems like the multiverse explanation equally well explains the data with perhaps more parsimony because it doesn't require a divine creator compared with the creator hypothesis. So can you use quantum energy as a weapon? Quantum energy, it's not really a thing. How are spacesuits holding oxygen in minus 240 degrees in a vacuum? Because it's not minus 240 degrees in the place where the oxygen is. What was your largest accomplishment in your field so far? Largest? I don't know. Like, I've had some papers that I'm really proud of. Why can mathematics describe physics almost perfectly? The axioms are self-made. I don't know. I kind of suspect it's because the way that we do physics is probably derivative of the way that our psychology works. And so the way that we do physics and the way that we think about physics and the way that we think about mathematics, these are both derivative from our psychology. And so it's not surprising that the way that we do one thing would be relevant for the way that we do another thing. Well, multiple worlds just means you need to explain further fine-tuning. No. What further fine-tuning? Can you use quantum entanglement as a means for communication between very long distances? No, you can't. There's something called the no communication theorem, which prevents that. Thoughts on Stephen Meyer? Is he the creationist physicist? Is he the guy that... Yeah, he's the creationist physicist, I think. Actually, I don't even think he's a physicist. He has a bachelor's of science in earth science and a bachelor's of art in physics. He got a PhD in the history of science and the philosophy of science. Yeah, I don't think very highly of him. Where were they published? So I've had a few papers published in Classical and Quantum Gravity, which is a pretty good journal that I'm pretty proud of. I had a paper published in Communications of Contemporary Mathematics, which I'm also kind of proud of. Let's skip down to the bottom, so because I'm kind of behind. And oh, let's double check, make sure I didn't miss any cache. Okay, I didn't. Oh, did I just get another invite to review for JGEA? I literally just did a... Wait a minute. Didn't they ask me to review that? Oh, okay, so this is awkward. So I got asked to review a paper like 4 months ago, something like this, for a different journal. And I think it's for a different... Oh, no, I'm sorry. Oh, that's just a follow-up reminder. What? So confused. Oh, this is just, they sent me a follow-up reminder email like a day later. It's so weird. Why would they only lasted a day? I don't know why, but a lot of stuff just came in, so I'm just gonna go through the super chats really quick. Oh no, I already answered that. I already answered that. Oh, I already answered all of those. That's strange. Okay, let's keep reading. Come on, go away. Okay, I already read that one, don't worry. Do you need standard physics like Newton and kinematics for nuclear physics? In principle, I guess you don't, but you really ought know it. Like, otherwise you probably don't have the good the good intuition or the good foundations. From Alex Tyler Gaming with the $5. What exactly happens chemically and medically inside the brain of someone who is unable to share normal emotions like psycho or sociopath? I'm not a psychiatrist, I'm a physicist. So you may have sent that to the wrong person, which I'm apologize for. I have no idea what the answer to that is. Is it true that the universe is isotropic in a large scale? That's at least part of the cosmological principle. But that's to be determined, right? There are some features of the universe that seem like they might be too big in order for the universe to be isotropic, but why would a purposeless universe generate beings wired to seek objective truth and moral order? You should go talk to a philosopher about that. I'm in physics mode. Can someone with a master's in physics be called a physicist? If you're doing research in physics, then sure. If you're not, then probably not. I don't know where all of the questions went. Did my internet just poop out? Okay, never mind. Questions just, well, we have like 700 people between platforms, I think. 175 on the vertical. We have 345 on TikTok, and then we have, what, 145 on horizontal. So yeah, I don't know where all the questions are, but that's fine. Okay, there's the questions. What is the biggest form of scientific mathematical proof towards the multiverse being real? Probably the, what's it called? The smoothness of the universe. The universe is very, very, very smooth, and it looks very, very, very flat, which seems to suggest that there is at least it's strong evidence for this idea called inflation, and inflation naturally lends itself to a multiverse. From Git Stanfield again. Thank you for the $10 again, bud. It's always good to see you, and I always appreciate you. Last question. What suggestions that you'd have for someone starting in physics with no background in mathematics nor physics in general at all? Reading books? Yeah, reading books is going to help. If you read the book series by Sean Carroll called The Biggest Ideas in the Universe, there's currently 2 of 3 volumes out right now. Reading those will definitely help give you like an idea as to like what physics is actually like. From Helium Biscuits with the $5. On December 18th, you were on with the Flurf looking at latitude angles to Polaris. You calculated Polaris at a height of about 3,000 miles. Can you elaborate? Yeah, so the point so yeah, I remember this live. The idea is that if the Earth were flat and Polaris were simply located above the North Pole, like directly above the North Pole, like the center of the disk, and you know how far away you are from the North Pole in miles, then you can just figure out using an angle, just by measuring the angle to Polaris, by looking outside and using like a protractor or a sextant, you can figure out how high above the North Pole Polaris must be, if indeed Polaris is above the North Pole and the Earth is flat. And so for the flat earther I was talking to, given the distance that he was from the North Pole and given the angle that he observed this Polaris to be at, that implies that Polaris must be about 3,000 miles up. So that was the context there. How many light years between Earth to Orion? Orion isn't a star, it's a constellation, and the individual stars in the constellation are not, like, they're not necessarily close to each other. Is space filled with the corpses of time travelers from the future that forgot the Earth moves? Probably, yeah. No, I kid. Probably not. Is time real or an illusion created by entropy? If time isn't fundamental, cause and effect are bookkeeping, not law. So what does seem to be real is that we live in a 4-dimensional space-time. Now, the question is why does time appear to flow? And the flow of time could be related to entropy. The apparent flow of time could be related to entropy. But that doesn't mean that there isn't a time-like character and a space-like character to the different dimensions of our universe, and that those are distinct from each other. I'm not asking you to solve ethics. I'm asking how, on your view of a purposeless universe, reflective moral reasoning arises that seems connected to your view of reality, not just philosophy. Well, it's connected to, like, it's definitely a philosophical question, right? Like, it's not even granted that, like, our universe is purposeless. Like, you could believe in, like, the axiological universe. You could be an axiological naturalist and think that our universe has purpose, or our universe is even directed towards an end without having a God in it. Now, my view is merely that like moral reasoning arises from like evolutionary processes. But like if you wanted a more in-depth conversation, that's a question for like a naturalist philosopher. How difficult to get a PhD in physics, not in terms of technical difficulty, but finding new info. I don't know what you mean by finding new info. It's hard. It's not for the faint of heart, I should say. Yo, we used to watch on the Clock app. I didn't know you stream on here too. Yep, I do. I also stream on the Clock app. We're currently live there, actually. Which star in the Orion constellation? And then Blitz will work it out. Yeah, I mean, I'll just Google it, but you could Google it too. Is time just the conversion of gravity into entropy? No, I don't think so. From Preston Devaney with the $2, can you explain the Andromeda paradox? Yeah, so the Andromeda paradox is merely a counterintuitive result. A counterintuitive result arising from the relativity of simultaneity in special relativity. So the idea is, and there's a diagram that I'll show you just to kind of make sense of this. So, one sec, relativity of simultaneity. Let me show you a diagram. So, there and there. So this is a space-time diagram, also sometimes called a Minkowski diagram. What you want to think about is that the vertical direction, in the vertical direction, just ignore the red for now. In the vertical direction, the vertical direction is time, and the horizontal direction is space. So you have x here and you have t here. And so from the perspective of A, where A is not moving, you can think of they're just moving straight up along their time axis. However, if on the other hand, someone at A decided to move faster, well, from their perspective, they would be moving straight along this red line. In fact, well, let's not worry about B yet. They'd be moving along this red line instead, because they're moving through space relative to the person who's not moving. They'd be moving through space at some rate. So they would cover some amount of space in some amount of time. But because of special relativity, what that does is it causes what they call now, which is this red line, what they call now tilts relative to what the stationary person calls now. The stationary person calls now just a single individual moments of time, right? So at any given fixed moment of time, those would be the horizontal green lines. Those would be different nows. But for someone located at the same place but moving at a different speed, like if they're just passing by you at like some speed, the moment they pass by you at a slightly different speed, what they call now is different. It's tilted. See all these tilted red lines? Those would be the moments of now for them. And so what that means is if you look at the moment of now at some distant place, the time difference between the two nows can be very, very large if you go far enough away, because that angle diverges. It gets bigger and bigger the further away you get. And so if you consider two people traveling relative to one another, and then you look at their slices of now at somewhere that's super far away, like in the Andromeda galaxy, then you could have a small speed difference here, and that would account for an enormous temporal difference far away between their relative nows. That's what the Andromeda paradox is about. And from Helium Biscuits with the $2, so the 3,000 miles to Polaris means definitely not flat. Sorry, the 3,000 miles to Polaris just means that that's what it would have to be the case if the Earth were flat. But then you would just go and you would calculate it from some other position. You would get a different number, and you would find that Polaris must be both 3,000 miles up and 3,500 miles up, and 4,000 miles up, and it can't be both. So it means that it's definitely not flat. And from Timotei Mares with the 200 Czech crowns, figuring out the black body radiation led to a breakthrough in physics, opening a whole new field. Can we hope for similar trajectory with black hole physics? People think that, but it's really hard to actually do measurements with black holes, whereas it's much easier to do measurements with black body radiation. But just, by the way, just to be clear, with the Andromeda paradox, it's not that two different people traveling at different speeds will receive signals from Andromeda coming from different times. That's not the case. It's only about the instantaneous slices of time, but you can't actually look at what's going on instantaneously there, because light has a travel time to get to you. So like the fact that like once you combine this simultaneity of relativity with time dilation and length contraction, from the moving person's perspective, everything syncs back up when you're talking about light signals getting to you. Special relativity is actually just a lot of plane geometry. It's just kind of counterintuitive plane geometry. But honestly, you don't need calculus to do special relativity. Simple high school algebra is enough to like go and like actually do calculations in special relativity. It's just counterintuitive. Are there any physics-related issues you think have been handled poorly by mainstream media recently? Not that I can think of. About ds and gr, I mean, like in static coordinates, we have entropy, and global, we have inflation. Yeah, so that's a good point. And this is a point that I realized after a conversation with a colleague, well, not a colleague in that he's a physicist too. After a conversation with him, entropy is not an observable. Entropy is not a diffeomorphism invariant quantity. Entropy very much depends on it's not an invariant observable, I should say. So entropy absolutely depends on things like coordinate choices. In global coordinates, you don't by inflation you just mean like expansion. So again, expansion rate is not an observable. What is observable is like if you plop down test masses, you could measure like geodesic deviation. If they're like if you measure them as initially at rest with respect to each other, you like by bouncing light beams off of them, and then you wait, like you can measure geodesic deviation. Those things are like diffeomorphism invariant observables, like coordinate invariant observables. But like those kinds of things are very coordinate dependent quantities, like the expansion rates and like entropy and things like that. From Billy the Minion with the $10, I don't know enough about physics. What are some of the topics you're most interested in? What fields or areas excite you the most in physics? Thank you. Have a wonderful day. One sec. I'll answer your question in a moment. So the topics I'm most interested in and the topics I'm most knowledgeable in, these are going to be topics on relativity. General relativity specifically, things even more specifically, asymptotics, especially formal asymptotics and relativity, like things like conformal infinities and the like. I'm also interested in like quantum gravity, but I'm not particularly interested in like stringy quantum gravity or loop quantum gravity. I'm kind of interested in the more fringe or the more niche ideas of quantum gravity that kind of just get at some new intuitions for it, or like new ways of thinking about it, not about actually creating a whole theory of quantum gravity. I'm interested in like the kind of fringy ways to probe ideas about quantum gravity. So those are the kind of things that get me excited. Also, early universe cosmology is really exciting for me, and I'm trying to break into it. I'm trying to write more and read more about it. The JWST found what seems like evidence for dark matter by looking at and comparing images for Hubble. How likely would it be for a gravity particle to make up dark matter, and what would it mean? So it can't be a gravity particle that makes up dark matter. Gravity particles, if they exist, are going to be massless, at least if general relativity is true. And so we know that dark matter, if it's a particle, is not made of massless particles. It's going to be made of heavy particles that move slowly. And gravity particles, in fact, we actually know for a fact that gravitational waves, which would be made of gravity particles, travel at if not the speed of light, then very close to the speed of light, which would further then imply that even if the gravity particles aren't massless, like maybe GR is only slightly wrong, they do have to be very, very light. So we know that dark matter can't be made of that. Can you explain tensors with respect to general relativity? I find tensors very confusing. So a tensor is merely a quantity that think of it as like a geometric quantity. Like you know about all of this stuff with like indices and stuff like that, and those things change depending on how you change your coordinates. The tensor is just a geometric quantity that, because it has directions associated with it, you have to specify coordinates in order to extract information about the geometry. But the object itself, it's just like, imagine just like having like a compass, for example. Like a compass, the line on a compass is going to point in a certain direction, regardless of what coordinates you're using. It's going to point in that direction. But if you rotate your compass, for example, the arrow might now point east instead of pointing towards north. And so that's like changing your coordinates, but the arrows never change direction. You just changed your coordinates. So the arrow would be an example of a tensor. Now in this case, it's a 3 tensor and not a 4 tensor. But the point still stands. These are geometric objects, and what makes them confusing is just that they have these like components. They're like multi-dimensional matrices. They have these components that change in a complicated way when you transform coordinates, but that's just because of the way that the coordinates are transforming, which affects the way that you view directions, but it has nothing to do with actually changing the tensor. Yeah, also a tensor is just an object that transforms like a tensor. Do black holes have more entropy than, say, the sun or the Earth? Yes, in the standard way of understanding entropy of black holes, absolutely. From Bogdan Dukic, with the 5 CHF, I think that's no, that's Swiss francs, I think. Navier-Stokes, example of 90-degree water channel resulting in infinite speeds at the corner. Wouldn't adding relativity to the equation solve that problem? I don't think that that's the problem with Navier-Stokes. The problem with Navier-Stokes isn't that it violates relativity, because it's a classical theory. We expect it's going to violate relativity because it's classical. The issue is that we don't know how to solve it. We don't know how to, or that's not true either. The issue is that we don't know how to show that there always exists a unique solution for at least some short time. Swiss francs it is. Ah, good. Oh, I don't know why it just jumped down. I don't know why it's been doing this, but maybe I need to update the website or the program I use. Is physics a stagnant field? No, definitely not. From Git Stanfield with the $5. How do all frequencies of light occupy space simultaneously? For instance, how does the sun release visual, like you mean optical, infrared, etc., but spatially the same? Well, look, it's the same way that you can have different frequencies of sound occupying the same space. Sound waves. Okay. So the way to think about this is that what's actually traveling through space, if you want to think of it, let's think about sound waves because they're easier to think of. What's actually traveling through space is you have regions of high pressure next to regions of low pressure. But if you have a complicated sound wave, like let's say you have a whole bunch of different frequencies, let's say I'm talking. Well, my voice is not a single frequency. It's a whole bunch of different frequencies added together and stacked on top of each other in complicated ways. What's happening is not a regularly spaced high frequency, low frequency, high frequency, low frequency. It varies. Like there's high frequency, then a long low frequency, then like maybe a long high frequency, then a short low frequency. It varies. And the way that it varies can be decomposed into a whole bunch of different waves stacked on top of each other. And then you add them together and you get this new waveform. But what's coming from the sun is it's a more complicated waveform that can be decomposed into many different individual waveforms, and the different parts of that waveform that have different frequencies, they will interact in different ways. So that's why that's why we see them differently, because the part of the waveform that comes from the red light, that will interact with our cones in one way. The part of the waveform that interacts with that produces the green part of that waveform will interact with our cones in a different way, etc. How do I send those donation questions? It's a YouTube only thing. So you can make a YouTube channel and then you can do that. Does the time dilate more near a mass such as the Earth because space-time contains potential energy which is sacrificed or stretched to allow for a region of matter energy to exist within time? No, that's not the right way to think about it. The right way to think about it is that merely massive objects curve space-time. And that includes curving time. It includes just changing the way that time flows, in the same way that it changes the way that space is shaped, right? Let me make sure that I haven't missed anything that I should have missed, that I shouldn't have missed. Okay. Someone asked about my time theory. What time theory? Is there any evidence for the B theory? Well, general relativity is generally viewed, or it's generally thought that if general relativity is true, then the Beer theory of time is the more parsimonious theory. How can light have energy but no mass? Well, mass and energy aren't intrinsically related, despite what you might think from E equals mc squared. E equals mc squared is only the formula for the energy of an object if that object is not moving, but light is moving, so that's not the correct formula. Can a single photon be multiple colors, i.e. have multiple frequencies? Not really, but it depends on how you define what a photon is. Generally, we think of a photon as being a pure momentum state, and pure momentum states have a single frequency. What theory of time do you subscribe to? What's the question? Oh, I subscribe to the B theory of time. How big would the butterfly in the butterfly effect need to be to actually cause a hurricane? Well, the point is that weather is described by a dynamic or a chaotic system. And so even a tiny, tiny change, like the size of a butterfly, like a change caused by the butterfly flapping its wings, that in principle could be enough to change the course of some future wind front or wave or wind pattern that causes a hurricane. So like there's like it could be arbitrarily small actually. What actually collapses the wave function if the universe existed before observers? Well, it's not even clear that the wave function collapses at all. This is the view that most cosmologists take, that there is no wave function collapse whatsoever, and that merely the wave function is just a thing that evolves unitarily, and you know, and that's just the way it is. Now, that said, it doesn't require observers. Like if you're taking the Copenhagen interpretation, this doesn't require like observers with minds or anything. It just requires a big thing interacting with a small thing. Is the universe expanding or contracting? The evidence points to the universe expanding, yeah. I remember Blitz say something about buying his reference sheet. It's, so I don't want to make it sound like I'm selling it. It's basically if you become a member on YouTube, it's like $4 or $5 a month. One of the perks that you get, along with getting emojis and getting access to like the other member things, you also I also just send you a link to my reference notes. But like yeah, so that's the way to do it. I had membership before I made this available. I just use this as an incentive so you guys can support a creator that you like. Reference notes, yes, reference notes. So I have like some notes that I use for myself that keep track of like, you know, papers and studies and examples and counterexamples and arguments and counter arguments and sources and stuff for all of my debate stuff that I've just kind of been assembling over the last few years because, you know, it's hard to keep track of everything off the dome. It's easier to have like a, you know, like a document that you wrote up that has like all of the relevant things, all of the relevant sources in one place. And so like I make that available for you guys if you guys want to support me. From Cat's Meow with the 10 pounds. I appreciate that. Thank you so much. Currently studying classical field theory, do you have any insights into how different representations of Lorentz Lie algebra correspond to different particles? It's so confusing. I don't have a good intuition for this. So what I can say is that you basically want to look at, into how different representations correspond to different particles. Well, look, so the way that we do physics today is we do it in terms of, like the way that we think of physics is that we think of, or let me even say forces. We think of forces as being generated by different Lie algebras. So like you can think of the electromagnetic forces being generated by a U1 Lie algebra. And so what that means is that the way that, and the way that we talk about how that force behaves on a particle is by covariant differentiation, where the connection is a, well, it's a Lie algebra valued diffeomorphism. Sorry, it's a Lie algebra, an adjoint representation of it. It's a one form taking values in the adjoint representation of the Lie algebra. And then you can form a covariant derivative where it's the exterior derivative plus the connection. And once you incorporate that covariant derivative, now your kinetic terms include forces. And so the action of the one form taking values in Lie algebra endomorphisms, the action of that on the particle will depend on the particle's representation. And so different particles, if they occupy different representations, will have different force. Well, the forces acting on them will be different. Similarly, we can think of the way that we do like coordinate transformations and so on. So that's with regard to like gauge theory. The way that we do coordinate transformations, well, you want your theory to respect, you want your like Lagrangian, for example, to respect Lorentz transformations, for example. And so that means that in order for your Lagrangian to be invariant under some sort of symmetry transformation, all of the terms in your Lagrangian have to transform in certain ways. Like all of your field content has to transform in certain ways under the Lorentz transformations. And so that means that you have to pick out a representation that those fields occupy. And they will transform in different ways depending on the representation. And so you can have a representation that's like the spin representation, you can have a vector representation, a tensor representation, or whatever. And so the different particles will just respond in different ways to coordinate transformations for that reason. Otherwise it wouldn't make sense to apply a Lorentz transformation to a particle. Like, how does the Lorentz transformation act on that, right? It has to take a value in a Lorentz, in a representation. Otherwise, there'd be no connection between the way the particle is and the coordinate transformation or the Lorentz transformation. I hope that helps. The intuition there is tricky, especially with like the little group for the mass of the particle, but in the standard model anyway, all of the particles are massless, and they only gain mass through their interaction with the Higgs. So you can treat them as massless particles, and then you don't have to worry about like massive representations or anything like that. From Garain with the $10, thank you so much. Does inflation/expansion only stretch space or space-time? If the latter, can we really say the universe is 13.7 billion years? In other words, was the first second after the Big Bang equal to a modern second? Yeah, so it only stretches space. There's no temporal expansion here, at least not in co-moving coordinates, or not in like in standard cosmological coordinates. But to be clear, expansion is like a coordinate-dependent statement. Favorite beginner-friendly science book? Probably anything by Neil deGrasse Tyson is good. You ain't ever seen no particle stop lying. In fact, that's all we ever see. That's what light is. On a scale, from a scale of 1 to 10, how convinced are you of material consciousness? Like 8 or 9. Are continuous symmetry groups the same thing as harmonies for a slice of time? Harmonies? I don't know what a harmony is in that context. What happened? There used to be a lot more people watching the stream. This is a Ask a Physicist stream. Those tend to be slower, which is fine. They tend to go slower, and it's actually probably a good thing that they tend to go slower, because otherwise I would have too many questions. I would miss a lot. We still have, though, 300 people on 330 people on YouTube or on TikTok, and then like 290 people between the two YouTube streams. So that's still like 600 people. Why do you have a problem with Neil? I don't have a problem. I don't have a problem with him. He does say some wrong things sometimes, but like I don't have a problem with him. Although I don't know him personally, and I don't know about the truth of the allegations against him personally. But like as far as a science communicator goes, he's very good. Isn't it a later stream? Maybe not the usual crowd. Yeah, it is later because I went out for lunch or went out for breakfast with some friends. Have you heard the latest Flurf theory that light has no speed and is in fact instant over all distances? Well, that'd be crazy if true, but we can measure the speed of light, so. Is it true that light takes... In fact, I'd love for somebody to bring that up during the Flurf debate. How to get through the first years in uni. It's hard. University is a lot different now than it was, 10, 15 years ago when I was in university. Is it true that light takes millions of years to get from the center to the surface of the sun? If so, why? I think the number that's usually offered is 100,000 years, but yeah, it still takes a long time. And the idea is merely that the center of the sun is the center of the sun is dense, and it's charged, right? It's a plasma. And so you have light that's created at the center, It's very high energy light. And then it goes a centimeter, or even perhaps less, and it's re-emitted in a random direction. And eventually it works its way out, but it's basically just kind of billiard balling around the entire sun, and so it takes a long time. What force caused the spiraling nature of everything in the universe? Not everything is spiraling. I mean, go look at elliptical or ellipsoidal galaxies. Those are just big blobs. How hard is quantum mechanics? Mathematically, it's not that hard. Intuitively, it's pretty tricky. Is reality fundamentally deterministic or fundamentally probabilistic? Which side are you on? I'm on the side of fundamentally deterministic from a quantum point of view. So in some sense, the many worlds interpretation is a deterministic theory of physics, but that doesn't mean that we can make non-probabilistic predictions about what's going on in our branch. I'm currently studying mathematics. Is there any other subject that is super close to mathematics? Yeah, physics. Will those blob galaxies turn into spirals eventually? No, no. Spiral galaxies generally inevitably turn into blobs by mergers. Why do more galaxies spin one way than the other? So as far as I can tell, this was the result of a single study from like a year and a half ago, maybe almost 2 years ago now, I think at this point. And I don't know if it's been followed up on. And if so, then it may have just been like a bad analysis that the guy did. Don't clown me, but how does gravity affect gas without an atmosphere? If something has mass, then it's actually, you don't even need mass, honestly. Everything is affected by gravity. So if you have something that's not, if you have something that's initially at rest, but there's like a gravitational mass nearby, like a planet or something, the thing will fall towards the thing that is producing the gravity. That includes gas molecules. Now, gas molecules move very fast, so sometimes they will go up really far away and then come back down in like a long parabolic orbit, but like they do experience gravity, yeah. Love when Dr. Blitz speaks with his hands. Look, if you watch any of my videos, you'll see me jiggling like this and my shoulders moving. It's because I'm talking with my hands, even when I'm reading a script. And I really try to not do it, but for some reason my brain doesn't work unless my hands are moving. Which is hilarious, by the way. So what happens to the ISS gas pressure when its hull is punctured? Oh, well, most of it will just remain as part of the Earth's atmosphere. Some of it might escape. It depends on how fast the gas is moving and depends on what the local escape velocity is. But yeah, most of it will just become part of Earth's atmosphere again. Because the ISS is just not very high. Does quantum mechanics remain exactly linear at all scales, or does it break down to gravitation effects? We don't know. We just don't know. Is this a good analogy to explain space-time? If the universe is like a painting, then space-time would be the canvas and matter energy would be the paint. Not really, because at least after Einstein came about, we realized that the space-time is also dynamical. Like it's also interacting with the matter energy or the mass energy, and it like can change in response to it. It's not just some static thing. What kind of card games do you play? I play Magic the Gathering. Are gravitons real? We at least have some good reason to think that they, at least to some approximation, they exist. I've never seen someone talk with their shoulders. It's not because I'm talking with my shoulders, it's because I'm talking with my hands, and that makes my shoulders move. I don't know where I got that from either. I mean, my mom does it, but I don't know if that's like a genetic trait. Why isn't the inability to measure the one-way speed of light a problem for relativity? Because relativity doesn't actually require a one-way speed of light to have any particular value. Relativity is consistent with any one-way speed of light. Special relativity is anyway. General relativity gets a lot messier. Scroll down to the bottom, read some new questions. Is the cosmological constant a fundamental parameter or an anthropic quantity? Your opinion? I don't know. I'm actually of the opinion that there isn't a cosmological constant, and rather that there's just a dark energy density that arises from some other mechanism, and it's perhaps dynamical. From Sans Sensibility with the $10, what made you decide to choose the lava lamp? Hashtag stone, hashtag lava, hashtag salt, hashtag unapologetic. I don't remember the context, but somebody brought it up. Oh, no. I was in a conversation with somebody. I was talking about how Cloudflare used to use lava, like a wall of lava lamps to produce random number generator, like as a random number generator to seed their encryption stuff. And the guy I was talking to said that randomness can only come from God. And I'm like, well, does that make a lava lamp God? Because Cloudflare uses these to generate randomness. And he said, well, I guess it does. And I'm like, oh, maybe that's it. Maybe that's the bit. And so it kind of grew from there. And now we have Leviticus, and we have the Apostle Matthew. We have the Levatican rather. Lavarus was raised from the dead. We have all the good puns. Oh, people were asking what I play in Magic. I play Commander, and so my primary colors are Teamer. I play lots of green, lots of blue, and a decent amount of red. And like probably my favorite deck is actually Teamer. My second favorite deck is Mono Green. But yeah, I have a lot of decks that are in those colors generally. Lol, you would. Yeah, that's probably that's fair. That's fair. Thank you for the jet, by the way, Jason. I appreciate you. From Unable to Squat with the £5. Any advice for a math student with no physics modules that wants to do maths heavy physics? I really only do analysis, PDEs, algebra, and number theory. Well, number theory, you're probably not going to find a lot of relevance there. But if you do like analysis, well, okay, so it depends. Do you do analysis or do you do algebra, right? Because if you do analysis and PDEs, you can get into some really hardcore like general relativity stuff. If you're really strong in algebra, you can get deep into like algebraic quantum field theory and stuff like that. But you will need to take the basics. Like if you want to do physics, like you just need to learn the basic stuff. So unfortunately, that would mean that you'd have to start from scratch. Sorry, I didn't click your thing earlier. Everybody's like, of course you play Teamer. Of course you play Teamer. What does that mean? I would think that you guys would think that I'm a Simic player, which I basically am with a splash of red, right? Simic and Izzet, I guess, are like the the nerdy colors, right? Sorry. Why is strangeness conserved in the strong interaction? In fact, all flavor quantum numbers are conserved in the strong interaction, just because the strong interaction only affects color. It only affects color charge. What's your thought on the theist argument of the universe not being able to actualize its own potential, thus needing an actualizer? I think that argument's probably like 2,000 years out of date. All right, y'all. I think that we're probably gonna. Oh, let me just double check. I think that we're probably gonna end the live here, because we're running a bit over, and I want to make sure that I still have time to do other things. I have a lot of stuff to take care of today. So thank you guys so much for being here. Remember, if you want to get announcements about when I'm live, about when I post videos, if you want to talk with like-minded people, make sure to join the Discord server so long as you're 18 years or older. If you want to do that, go to discord.gg/drblitz. That is the way to do it. And I'll see you guys there. In the meantime, I won't be live again until tomorrow at around 9 a.m. Mountain Time or 8 a.m. Pacific Time. So I'll see you guys then. Take care, everybody. Oh, wait, hold on. Let me make sure I don't have a Cash App. Okay, no Cash Apps. We're good. Take care. Bye-bye.